So I made this review of chapter 6 to kind of get everything that you learned all in one place to kind of go over it. All right, so the first thing that I want y'all to do is read the problem and then ask yourself, is there a treatment being applied? If the answer to that is yes, you've got an experiment. If the answer to that question is no, you've got an observational study. In the observational study world, this was chapter 5 that we did last 9 weeks. We could either have an observational study, it's just a comparative observational study. We could be sampling, and we could be doing a census. Sampling is when we look at part to generalize the whole, and there were 3 types: random sampling, semi-random, and non-random. The random had the least bias, and the non-random had the most bias. There was only one kind of random sampling, and that was the simple random sample. There were 3 semi-random samples. That was the stratified, the cluster, and the multi-stage. If you want a review of those, go look at the video for the review for chapter 5. And the most bias were the systematic, voluntary, and convenience sample. If you're over on this side of the flowchart, you can only get a correlation from your data. If you come over here to the yes side, you're looking at an experiment. This is where we have a cause and effect relationship. If this happens, then this will happen. We can prove cause and effect with an experiment. How is data collected in an experiment? Is it a completely randomized design? Are the subjects, you can see the little line right here, the subjects are directly split into the treatment and the placebo. There can be more than one treatment. The subjects are just directly split into those treatments and the placebo or the control group, and then we compare the response. We could have a block design. So the next type of experiment is a block design, and let's follow the arrow. This is a picture of what that looks like. We've got the subjects split up into the blocks, and then these blocks are grouped. There's a blocking variable. And then this block is split up into treatment and placebo, and this block is split into treatment and placebo, and then we compare the responses. And then the last type of experiment is a matched pairs. And in matched pairs, my subjects are split into pairs. And then in those pairs, one person in the pair is a treatment and one person in the pair has the placebo or the other treatment. A matched pair, your pair can be yourself. I can be paired with myself for a matched pairs design. All right, and then let's look at these splats right here. Lurking variables can affect any of these experiments. If there's any variables that are lurking in the background, either over here or over here on the observational studies that are not the explanatory, the input, or the response, the output, they're called lurking variables. So for example, if I am trying to do an experiment that says if I study harder or more for my test, I should get a better test grade. Well, a lurking variable to that situation would be how much sleep I got the night before. What kind of breakfast did I have that day? There are things that are happening in our lives that have nothing to do with whether or not we studied, whether we'll get a good grade on the test. The placebo group is, or sorry, the placebo effect is when I give someone a treatment that they have a response to that treatment, even if there's no active ingredient. Okay, so sometimes people, just because I'm given a diet pill, will automatically start losing weight. Now, that diet pill may or may not have any active ingredient in it. The placebo effect would be if you gave me a diet pill that had no active ingredient and I still lost weight, that would be called the placebo effect. To reduce bias, we are going to randomize. The more random our experiment is, the less bias we have. The randomization comes in at these arrows. So for right here in the block, I pick the block. There's nothing random about that. But when I go into the treatment and placebo, I have to randomly pick which part of block 1 goes to the treatment and randomly pick which part of block 2 goes to block 1 goes to the placebo. The random is, I don't get to randomly pick, quote unquote, all right? The computer or table B is how we randomly pick. I have nothing to do with it. As soon as I say I pick, it's not random anymore. I have to have the computer or table B pick in order for it to be random. If I want to reduce the variability, I have to take a larger sample. Okay, so in an experiment, why we do it is to get a cause and effect relationship, to have control over the lurking variables, and to reduce the variability. How we do it are the principles. I have to be able to replicate or produce the same results multiple times. I have to provide a control group or a placebo group, and I have to randomize which groupings the subjects get placed into. And the last thing in experiments is the ethics. Okay, so maybe I can put a little bubble here that says should. This is the should part of experiments. Just because I come up with an idea of something I want to test doesn't mean that I should test it. The ways that we check to make sure that it's safe for humans to run this experiment is that the experiment must go through a review board. An independent person must look at my experiment and decide if it's safe to administer to human beings. Those humans that are being experimented on have to give informed consent. They have to know all of the risk, including the possibility that they might not get the actual treatment. They might get a placebo, and they have to consent. If you're not 18, your parents have to consent for you. And then the last part of ethics is the confidentiality. The data has to be kept confidential. So that does not mean that it has to be anonymous, okay? I might need to know a subject's name in order to follow up with them, but I cannot publish their specific data. All I can publish is the averages, the overall effects. So for example, I can't say Sally made a 62 on her test. That wouldn't be fair to put Sally's business out there like that. But I can say the average on the test was a 76. That doesn't put anyone's business out there. It just kind of lets you know where you stand for everyone else, or compared to everyone else. Okay, so a farmer wishes to produce, I'm going to go over some of the quiz problems from the last two quizzes with y'all real quick. It's something we didn't have a chance to do in class, so I wanted to make sure that you are on the same base or the same page with me. A farmer wishes to determine which two brands of baby pig pellets, Kent or Mormons, produce better weight gains. So they're giving me some information in there. They're saying two brands, baby pigs, Kent or Mormons, produce better weight gains. So I'm thinking here, I've got some subjects. I've got those pigs. Okay. And I've got Kent pellets, or I've got Mormon pellets. And then I want to look and see how much weight was gained. So my explanatory variable is the type of food, and the response variable is how much weight they've gained. Two of his sows, mama pigs, each gave birth to litters of 10 pigs on the same day. So he decides to give the baby pigs in litter A Kent pellets, while the pigs in litter B will get Mormon pellets. So we've got Kent, we've got Mormon, and then we're going to compare the weight. So my subjects are split into Kent and Mormon. So is this an experiment or an observational study? Okay, so the first thing I want to do to decide that is I want to come back and decide, is there a treatment applied? So let's go look at my problem. Was there a treatment applied? Yes, they got these pellets. They got these foods. Okay, so yes, there was a treatment applied, which means it is an experiment. Okay, so this is an experiment. Treatment was applied, it is an experiment. So let's go back and see, is it a completely randomized experiment, a block design, or a matched pairs? I took my pigs and immediately split them into the treatment and the control group. That makes this a random comparative experiment. All right, are there any lurking variables in this experiment? Well, we've got two different sows, two different mama pigs. Could the genetics be changing how they gain weight? Maybe one pig is more genetically disposed to be gaining weight. So the genetics, the DNA of the DNA, not E, that's from calculus. The DNA of the pigs could be lurking in the background and causing them to gain more weight than other pigs. All right, so let's look at this addition down here. It says if the farmer had fed If a farmer had fed Kent pellets to a simple random sample of 5 pigs from litter A and 5 pigs from litter B. Okay, wait a minute. Let me draw a picture. I've got my pigs and I'm splitting them into litter A and litter B. And then I'm taking this litter A and giving them, some of them Kent and some of them Mormon. And then litter B, some of them are getting the Kent and some of them are getting the Mormon. And then we're going to look at the weights of these pigs after he was done. So how does that change this? Okay, so let's go through our questions. Is there a treatment being applied? Yes, there is still a treatment being applied. They're given the different foods. So it's still an experiment. Okay, so now I've got a block here. This litter that they are in is a blocking variable. So now this becomes a block design. Because of this block design, I tried to eliminate the lurking variable of the DNA, because now pigs with DNA from mama A are getting both foods and pigs from mama B are getting both foods. So I can really see, is it the food making them gain weight or is it the DNA making them gain weight? So this blocking variable was able to help me eliminate that lurking variable. Okay, let's look at the next question. A drug company wants to test a new nasal spray that they think will help prevent the common cold. A group of 300 volunteers is available for this study. So I've got 300 subjects. Okay, half will be assigned the new nasal spray and the other half will receive a placebo. So here we go. They get the nasal spray and this group gets the placebo. At the end, the normal flu season, the proportion of those who received the nasal spray and got the flu will be compared to the ones who got the placebo and got the flu. So then I'm going to compare the number of flu cases. So my explanatory variable is the flu shot. Does the flu shot prevent us from getting the flu? That's my experimental variable. My response variable is the flu shot, number of flus, cases. So let's go back to the initial slide here. Is there a treatment being applied? Yes, they're getting a flu shot. We're over here. Is it a completely randomized experiment, a block design, or a matched pairs? Okay, so oops, that was the long one. Here we go. I take my subjects and I directly split them. That makes that a randomized design. You guys can hear my clock. Okay, hold on a second. I'm going to stop that. Okay, that makes that a randomized design. All right, let's make sure there's nothing else we need to review here. Are there any lurking variables? Was there a placebo effect? I have a control group. I have the placebo, so I can rule out any placebo effect. What if I wanted to reduce the variability? What would I have to do to reduce the variability in this? To reduce the variability, I would need to make this larger. I need to make the number of people I tested on bigger, and that would reduce my variability. Okay, here we go. A newspaper article headlined, "Marrying Young Can Be Beneficial." An article said, marriage is a good thing when it comes to cutting back on drinking and drugs. A University of Michigan Institute for Social Research studied 33,000 young adults, showed that young unmarried adults usually increased their alcohol, marijuana, and cocaine use when they left home to attend college. Those same people, however, decreased their drug and alcohol use when they got engaged or married. Some couples who lived together but were not engaged showed no drop in drug use. So my first question for you in this problem is there a treatment? Am I doing something to these people? Am I forcing them to get married, or am I just observing what's already happened? Okay, so let's go back and look at the problem. Okay, it says, what does it say? A Michigan study for social research studied these young adults. Okay, it doesn't say anything about setting up an experiment where I'm giving people the treatment of being married and then I'm forcing some couples not to get married. So there is no treatment That looks like a W. Oh my goodness. Okay, let's get rid of that first line. There is no treatment. If there's no treatment, okay, if there's no treatment, then this is an observational study. Okay, if this is an observational study, I can make no cause and effect relationships. I cannot, I repeat, not say that, so we cannot make any cause and effect relationships. I cannot say that marrying causes anything to decrease. Okay, I can't say, oops. I can't make the claim, or rather, I can't trust the claim that I see in here. I can say that there seems to be a relationship, there might be a correlation, but I can't say that this marriage causes that to happen. Okay, let me look at another one. An experiment. Oh, so this one even tells us right off the bat, okay? We don't have to do any guesswork right here. It tells us it's an experiment. Okay, so we have a treatment being applied. Compares the taste of new spaghetti sauce with the taste of a successful sauce. Each number of tasters tastes both sauce. So I've got my subjects. And I'm going to look at subject 1. And that subject 1 is going to taste sauce 1 and sauce 2, and then look at my taste. And then subject 2 is going to taste sauce 1 and sauce 2, and then compare the taste. And then subject 3 is going to taste sauce 1, sauce 2, and then we're going to compare the taste. So I've got to decide what kind of experiment this is. Okay, so let's look. If we're looking at the experiment here, is it a completely randomized design? Do I take my subjects and directly split them into the sauce and the placebo sauce and then compare taste? Do I split the subjects up by ethnicity and then compare the sauces? Or do I pair the pair the subject with itself and then have each person taste each sauce? The third one, matched pairs. So let me go see that one. Oops, I got to go back. Okay, so this is going to be a matched pairs design. Right about this. All right, there we go. Determine whether the nutritional benefits of little chocolate donuts can have a beneficial effect on the exam performance of STAT 001 students. Suppose all students who attend STAT 001 lectures during the fall term of 2010 are given a packages of Little Debbie little chocolate donuts at the beginning of each lecture, which they are encouraged to eat during the first 5 minutes of class. Students who attend the STAT 001 lectures in the spring will not be given the donuts. Unfortunately, any systematic difference between the fall term students and the spring term students' exams might be due to the fact that the spring term teacher is more skillful than the fall term teacher. Okay, so let's ask ourselves a question. Okay. Let's ask ourselves a question. And that question that we want to ask ourselves is there a treatment being applied? Yes, there is a treatment being applied. What was the treatment that was being applied? The treatment that was being applied is what we're given. we are given little chocolate donuts. Okay, so this is an experiment. So we are going to take our, let's see, what are we going to do? We are going to take our subjects. And we're splitting our subjects into those who get the donuts and those who don't get the donuts. Is that what we did? No, we did fall students and spring students. And then we split our fall into, oh no, these got the donuts. And these did not. So these are none for the donuts. And then we compared exam grades. Okay, so I need to decide whether this is a block design or whether this is a matched pairs design or whether this is a randomized design. So it's kind of misleading because it looks like I've blocked them on when they're taking their test or when they're taking their when they are taking their class. But really I haven't, because I'm not giving the kids in the fall both donuts and no donuts, and the kids in the spring both donuts and none. I'm using the classes to directly split them into donuts and none. So I've gone from subjects into treatment and placebo. That makes this a randomized design. So because the teachers aren't the same in the fall and the spring, the teacher here is a better teacher than the teacher here was. Other way around, the spring teacher is more skillful. So spring teacher is more skillful. That brings in a level of confounding. The teacher skill is a lurking variable. Okay, so let me write that down for y'all. The teacher's skill is a lurking variable which causes confounding. Okay, and last problem, I think. Yeah, this one's the last one. A researcher studied whether friendships affect the prices people set for selling things. She has 80 students, all imagine selling the same 6 items. Half the students assigned at random imagine selling items to a stranger. The other half imagine selling items to a friend. So I've got subjects. Half of them are going to sell to a stranger. And half of them are going to sell to a friend. Did I just write fiend? I before E except after C. Right. So that's right. Okay. And look, it's right here. Yeah. Okay, I spelled friend right. So I've assigned them. So the question is, let's see, let me go back to my questions. Okay. The question becomes, is there a treatment being applied? So I need to ask myself, is there a treatment being applied here? Yes, there is a treatment being applied. I'm being asked to imagine who I sell it to. So the treatment that is being applied is who is being sold to. Okay. And then we're going to compare the price. So the response variable is the price. The explanatory variable is who we're selling him to. And let's see, then the students were asked to set the price of the item. Okay. On average, those selling to friends set lower prices than those selling to strangers. So what kind of experiment is this? Did I break these subjects up by any blocking variable first, or did I just split them directly into the 2 treatments? I just split them into the treatments. So this is going to be a randomized block design. Okay, And what would I need to do in order to reduce the variability? To reduce the variability, instead of asking 80 people to do this, I could ask, I don't know, let's say 1,000 people. So if my subjects were up to 1,000, I would reduce the variability and therefore get a better result. All right, thanks guys.